In certain situations, an application might need to handle multiple tasks simultaneously. Now think about a word processor. It's not just about typing words anymore. Inside, it's like a busy workplace. One team is responsible for showing you pictures, okay, like that, and designs. Another team is always ready to catch every keystroke you make, and there's even a third team quietly checking your spelling and grammar in the background. Okay, so let's consider a busy web server as a second example. Okay, a web server receives requests from clients for web pages, images, and other content. Okay, imagine there are thousands of clients trying to access it at the same time. If the web server works in a traditional way, handling one client at a time, it would create long waiting times for everyone involved. Okay, when a request comes in, instead of creating a whole new process to deal with it, the server can create a new thread within the existing process. Okay, so this method is much more efficient than creating an entirely new process at each time, which consumes actually a lot of time and resource. So we use threads to handle multiple tasks concurrently. Here's how threads are typically employed in a web server scenario. So yeah, a client sends a request to the web server. Okay. Let me just a client sends a request to a web server for a specific web page, for example. Okay. Then the dispatcher thread accept the incoming request. Okay. And server at the same time it actually resumes listening others' request. Then dispatcher thread finds an available worker thread from the pool. Okay. This thread pool is a managed group of reusable threads designed to efficiently handle concurrent tasks. Okay. Unlike creating new threads for every task, we even create a thread pool, and this thread pool maintains a set of idle threads that are ready to execute tasks whenever needed. This approach ensures efficient utilization of system resources and improves responsiveness in web servers or database systems, well as in graphical user interfaces, without the overhead of creating new threads for every task. Okay, so the assigned worker thread then retrieves the content from the cache and sends it back to the client directly. Okay, so by utilizing threads in this way, the web server can handle multiple client requests concurrently, and also it improves responsiveness. Each worker thread operates independently, allowing the server to efficiently manage additional client requests simultaneously. Okay, so fundamentally, threads are a more efficient and developer-friendly way to achieve multitasking and concurrency in a program. Okay, so we may prefer creating threads over processes for a few simple reasons. Firstly, responsiveness. It refers to the quick and interactive feedback in applications where operations or user interactions avoid delays or freezes in program's response. Okay, so to enhance the responsiveness of interactive applications, we prefer multi-threading. For example, if the application is a single-threaded application, while using this application, if a time-consuming operation is initiated, like clicking a button, the entire application would become unresponsive until the operation completes. However, if this application would be multi-threaded, in this case, okay, time-consuming operations can be assigned to several different threads. This means that even if one part of the application is busy, other threads can continue running, With that way, it keeps the application being responsive to user interactions always, okay? So this is particularly important for user interfaces by allowing users not to experience delays or freezes during intensive operations. Secondly, let's look at resource sharing and simplicity. Threads share the memory and resources of the process they belong to by default, okay? Unlike processes which require explicit arrangements like shared memory or message passing for resource sharing, okay? Threads can share code and data within the same address space. This inherent resource sharing simplifies communication and coordination between different parts of the application, and which eventually makes development more efficient. It provides simplicity in a way that ensuring that multiple processes coexist peacefully in the same system can be a challenging task, okay? So processes are like a separate entities, and coordinating their activities can be complex. Threads, on the other hand, are like a smaller units of a program, and they share resources more easily. Okay, so as a third benefit, we can say that it is cost effective. The using of threads is cost effective. So creating and managing processes can be quite expensive in terms of system resources, okay? So the process creation, known as the fork system call, you remember from the last week, it consumes time and memory. In contrast, threads are lighter on resources, and they share the resources of the parent process. Allocating memory and switching context for threads is significantly more economical compared to processes, okay? For example, in Solaris, creating a process is approximately 30 times slower, okay, than creating a thread, and context switching is about 5 times slower. The difference in overhead makes multi-threading a more efficient choice, especially when system resources are a concern, okay? In the last benefit, we can say that multi-threading offers enhanced scalability, especially in multiprocessor architectures, okay? So in a multi-threaded application, threads can run in parallel on different processing cores, utilizing the full potential of the available processors. In contrast, a single-threaded process can only run on one processor, and regardless of the number of processors available. Multithreading allows applications to scale their performance according to the number of processors, making it a powerful technique for optimizing performance in modern multi-core systems. So these benefits collectively make multi-threaded programming a valuable approach, enhancing both the responsiveness and efficiency of application while maximizing the utilization of system resources, especially in multi-core environments.